Good evening, everyone. Welcome to the sixth episode of Focal Point presented by Aniridia North America. I am Janelle Collins, and I'm the host of Focal Point. This particular episode, our recording is a little different than most. Due to technical issues beyond our control, we only have a recording of the second half of this particular episode, which is unfortunate. I'm not super thrilled about that because we had a great conversation with Dr. Djalilian, and I'm a little bummed that I can't present to you the whole recording. However, I am happy to report that we do have the full transcript. And so if you are watching this on ANA's website, please just scroll to the bottom of this same page and you will find the transcript for the entire discussion there at the bottom. If you are viewing this on YouTube, please go to aniridiana.org, select resources from the menu, and select Focal Point and Focal Point Episode 6, and you will see at the bottom there the transcript underneath the bio for Dr. Jalilian. The first half of our discussion was all about prevention and treatment of corneal keratopathy in aniridia. And then the second half is where we really hit hard on the research questions. And so Dr. Jalilian was actually in the very beginning of outlining the various types of approaches that are currently being studied in order to address keratopathy. So he is kind of answering that question as we pick up with the recording. So without further ado, I'm going to bring you to the actual recording from with Dr. Jalilian and listen to his answers.
So that's one general approach, just is playing with that PAC6. Then, and we and others have published some studies on different drugs that have, at least in animal models, seem to help increase PAC6 and maybe improve the health of the epithelium and prolong their survival of those things. Then another general approach is try to improve the function of those stem cells by supporting them. And that's where we talked about those mesenchymal stem cells is what we're working on, or those umbilical cord stem cells, or basically supporting cells or supporting those stem cells that are there on the surface so they can function better.
Okay.
And that's a lot what we were focusing on, and a clinical trial that we have started basically to look at that question and whether topical or in a drop form, these, if you want to call it supportive factors, if given in an eye drop form, can help improve the function of the remaining stem cells on the surface of the eye and improve the health of the surface. So that, again, that remains to be seen. We still have to, we completed a safety study, so we know it's safe. Now we'll have to get into really looking at more of the testing the efficacy, and so we'll hopefully know more in a year or so when that study is done.
Okay.
And then now another way to think about how helping the surface of the eye is now how can we bring back those stem cells once they've been lost? How can we restore stem cell function? And that's probably the more challenging. But I mean, already there is, let's say there are studies that let's say manipulating certain genes, expression of certain genes on the surface of PAC6 being one of them, could help improve and bring back some of those lost stem cells. Now, I guess I should also mention this other approach, which is where when someone has lost all their stem cells in the body, all their limbal stem cells, then you try to use the stem cells from elsewhere and turn them into corneal stem cells or limbal stem cells and use those to help the surface of the eye. So again, those are active areas of research, and really the group in Japan are probably really there, have done the most work in this area, and have already tested that approach in some patients. Not in aniridia yet, but other patients with limbal stem cell deficiency. So still more to come. So I think that looks promising as
Okay, interesting. So there's really a lot of different things that they're looking into as to, and some better for the early disease, some better maybe later. Um, and I think you kind of already answered this. Diana had asked, are there any gene therapies being tried? And you kind of talked about that. There are some things involving, I would assume, CRISPR that people are trying.
perfect. Yes, exactly. Correcting the genetic defect, and then putting those cells back to the eye. Again, again, still a lot of those are at the cell culture level. I don't think we have seen much in the, yeah, no, sorry. We have seen, yeah, from Canada, Dr. Simpson has published some definitely studies showing that approach is viable, and you could get long-term um, expression of a gene that you have with through gene therapy you've introduced to the cornea.
Yeah, and I think she's
Exactly.
the one that has said before you got to cure the mouse before you can cure the human. And they haven't quite cured the mouse yet, but they're making progress towards that, is sort of what I think she said.
Yes, 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 exactly. No, no, the work that she's done looks very exciting and promising. For
Yeah,
sure.
that is exciting. Um, Somebody had sent me an article actually a while ago about nanoparticles from Northwestern. It was a new development, and it had to
Mm-hmm.
do with limbal stem cells. And I have to admit, when I hear nanoparticles, I start thinking like Avengers and stuff, right? But people were wondering, is this something that may help, aniridic patients down the road?
Yeah, yeah, perfect, perfect, great. So yeah, I know that study. I know the investigators quite well. Very nice work. So and this was obviously tested in a injury model, not in a
Right.
genetic fixed model. But it seems like their approach or their nanoparticles have mostly have anti-inflammatory and regenerative effects for the surface of the eye. Um, so yeah, those are both things that can be beneficial in an aniridic cornea as well. So um, potentially, yeah. I mean, I think it would be interesting to study those. But that reminds me of something really else, which is the nanoparticles also are another way to uh, deliver genes or proteins to the surface of the eye. So
Okay.
and so one of the approaches that we are looking at is really um, these what we call extracellular vesicles or exosomes, which
Hmm.
are which are these small, basically um, small particles that are secreted by cells, but they contain a lot of goodies. Let's say, but they're packed with um, proteins, RNA, other types of factors. That it's a way that cells can talk to each other. It's like a cell communication mechanism. But people have become very interested in those as a way to deliver therapeutic factors and also to enhance function and manipulate the function of the cells. So that's basically one of the approaches that we are looking at is how using these little packets, these which are very very tiny, sort of in the nanometer size, around 100 nanometer, and delivering factors to the surface of the eye. So again, so if you know all the right factors that you have to package into it,
Okay.
you can potentially again help support the remaining stem cells, but even potentially bring back stem cells to the surface of the eye.
Interesting. Interesting. Okay. Um, so I think it was Rachel that asked, is there any risk to the funding or the research for the studies that you are working on?
Yeah, good. I know. And I mean, of course, there's risk to all of us now who are dependent on NIH funding. So yeah, I mean, um, it's remains to be seen, but already we know from the budget that was passed that NIH budget was cut pretty significantly. So quite likely all investigators will have to take a cut to be able to continue their research programs. Um, yeah, it is going to be challenging times these next few years at least.
Yeah, for our researchers, for sure. Yeah.
Uh,
Okay. Thank you for addressing that. Um, so Vasil had asked, and I think it was on our list already, are there any current preclinical trials that are about to enter clinical trials? Any clinical trials that you know of that are coming up for people with aniridia?
um, yeah, besides our own trial, which is this mesenchymal stem cell derived factors, I'm trying to think if there are any other clinical trials. I mean, I haven't looked carefully to see. I mean, anything new that's about to start, but um, yeah, I mean, I think. Mm, yeah, I should have looked at this question. I could have looked it up on clinicaltrials.gov and I could have given a better answer. But I guess in terms of things that I know of, let's say not nothing that's immediately starting. I mean,
Right.
probably most things are a few years away.
Okay. That's kind of what I had heard too, but I wasn't sure if you had some secret knowledge that I had not heard about.
Yeah,
So,
nothing that I have heard. Nothing that I have heard that is that is that I would certainly refer a patient to say, oh, go travel to this place to get into that trial.
okay.
Nothing like that that I
Okay.
know of.
Now, Miguel from Nebraska asked a great question, I thought. He said, what are the biggest challenges in making some of these advanced keratopathy treatments accessible in like lower resource or rural areas?
Yeah, no, that's a great question. Really, yeah, really, as you know, I mean, this is not a common disease, and not as many physicians or ophthalmologists are are familiar with it
Right.
and can manage it. So it really are limited to mostly major academic centers in big cities. And those who are, I guess, hopefully close enough to these academic centers, they could potentially get access to it. But if they're far from an academic center, then that does limit what they'll have access to. No question. Yeah. So, and of course, any of these treatments, if they do become available, they're still. I mean, they'll likely not be. They won't be cheap. Let's say.
Right. Right. They never
So,
are, right?
yeah, exactly. Even for simple things like dry eyes, things that get approved are not cheap. I mean, let alone for a genetic disease or any kind of severe disease of the cornea, unfortunately. So, yeah, no, that there definitely is. There are problems in our healthcare system for sure.
Right.
That
Right. There is for
um,
sure. There's no doubt about that. Um,
yeah. So
before we go to
hopefully we can. Go ahead.
Oh, before we go, we only have, believe it or not, only about 5 minutes left. I can't believe this hour has gone that quickly. Um,
Exactly.
but before we go to that, Rita, the question she had been asking is with aniridia, is it true that you should wear sunglasses most of your life? Does that help the retina? Does it help the cornea? Does it, how does that help?
Great question. Yeah. I neglected to mention that. I think if someone is going to be spending, I mean, a decent amount of time outdoors, then I think it's definitely a good idea to wear sunglasses. We knew that UV light, I mean, is uh, for sure. They promotes aging of the cells. I mean, just look at our skin, and which is
Right.
exposed to this UV light, and for sure, it's the number one factor that, or one of the most important factors that can cause more accelerated aging of our skin. So yeah, definitely, I think wearing sunglasses for sure for someone who's going to be outdoors a decent amount of time, and especially if they're in the more closer with a more, if you're in the northern hemisphere, you're closer to the equator, or in this, or further south, or if you're in southern hemisphere, you're further north.
Right.
So for sure, I think it's good. Yeah, I think it's likely to be beneficial. Not just, I mean, for the cornea, aging of the cornea, but also we know it promotes cataract. Cataracts also can progress faster because of UV light. And back of the eye, probably. I mean, we don't know. It's hard to say. I mean, like with the back of the eye, how much is it sun related or UV related? But likely plays a role as well.
Okay. Okay. That's very helpful. So to wrap up, I've got really two questions. One of them's kind of complex, though, I guess multiple questions in one. Um, Susan from Illinois, who I know you know, Rebecca from Michigan, Sherry
Mhm.
from Maryland, lots of people have asked, do you think we're going to see cures and improvements in treatments in the next 3 to 5 years? And if so, which of those do you think hold the most promise?
Great. Oh, they're really putting me on the spot now. Uh, so, so there, I guess I'll answer that question in two ways. One, if we're thinking about preventive therapies that can slow down that, let's say, the loss of limbal stem cells on the surface of the eye. Um, that's probably, I mean, I would say quite likely, or there's a good chance, let's say, there's a good chance already there are drugs out there that can do that.
Okay.
Even among the drugs that are FDA approved, but I mean, not for the eye, but FDA approved for other indications. That
Right.
if we make them into an eye drop, likely the drug is already there, but we just have to figure out what is the right one and test it in models and feel confident then to take it to a clinical trial, which will likely take a good 2 to 3 years if you want to really show that it has an effect. So I would say something like that is, let's say, conceivable. Let's say that in maybe 3 years is a little bit ambitious, but 5 years, within 5 years, we could have something like that if we really, let's say, put our energy onto it and push through, we could probably get there.
Okay.
Now the other one were for more advanced limbal stem cell deficiency, which would bring back limbal stem cell function. That one's, yeah, I mean, I'm probably with the tools, I mean, the that we have already. I mean, like you said, like gene therapy, being able to introduce genes or deliver certain factors to the surface of the eye, or these just stem cell manipulations to change them from one stem cell type to the other. Again, likely that it's not like we probably already know how to, or we have all the parts that to be able to make a treatment happen. But again, it's we're not quite there. We just have to be able to put these pieces that we are. In other words, I don't think we need some kind of technological breakthrough that currently we don't have. In
Okay.
other words, probably the answer we have, the tools to make it happen are already out there.
Okay.
Uh, but it still requires some work. It's going to require work to figure out what are those factors that you have to deliver, how do you deliver it, and to do it safely. So that will take some work. I mean, that will take. I mean, let's say at the laboratory level, that I know I'm laughing because I've been saying like 3 to 5 years for the last 10 years. So,
Right?
so yeah, you try to think positive and be ambitious, but I mean, I really, yeah, I mean, I would say it's conceivable that in 3 to 5 years we could put all these pieces together and be able to bring back stem cells that have been lost to the surface of the eye. I mean, again, 3 to 5 years is on the ambitious side, especially given the funding environment we're going to have these
Right.
next couple of years.
Right.
But um, yeah, that's I mean, so I would say the therapies that can, let's say, restore the function of stem cells on the surface of the eye through some kind of gene or factor delivery is sort of probably the what I would what I would say is most promising approach. But to get to a clinical trial, we're a few years away at least before we
Sure.
can enter a clinical trial.
Okay, that's really helpful. So there is hope on the horizon, right? For all of this stuff.
For sure, yeah.
It's just not the horizon tomorrow. So,
Right.
right. So the key is, I often say that, my daughter's 17, but we, get new babies born every day with aniridia, and those new babies are going to have a whole different set of treatment available, for them when they're in their 20s and 30s than,
Absolutely. That I can say pretty confidently as well. I agree.
okay. Yeah, so it's an exciting thing to think about that, about what's
Right,
coming.
right.
And then my last question, and this is related to what Rebecca asked earlier. Yeah, and I'm going to ask it a slightly different way. But she said, I'm born and live with aniridia. She's in her early 30s. She's
Mhm.
asking what the best recommended, procedure would be for her. And I'm going to change that question slightly to be a little more generic. If you had a child who had aniridia and they hit
Mhm.
their 20s or 30s right now,
Mhm.
and they needed something done with their cornea,
Yep.
what would you do? A, and if for some reason they weren't a good candidate for stem cells procedures, then what would you do?
Yeah, that's tough, really tough. If they cannot replace, if they're not a candidate for stem cell transplantation, then your options are not. I mean, there are options out there. I mean, as you all know, I mean the artificial cornea, the keratoprosthesis,
Right.
particularly the Boston K Pro, is an option for someone young. Not really, it's a last resort,
Right.
just because for someone young and to have that in their eye for the rest of their life, it really is the risk of problems is cumulative. So over time, likely to have other problems. Glaucoma being a common one, probably one of the more common issues, but other things um, that could, again, with time, risk of complications are increased. So yeah, I mean, I would say that's if they were going to do that, I would say only one. I would only consider it for one eye and
Right.
leave the other eye alone, because chances are for that young person, and they're in the foreseeable future, we're going to have hopefully safer and more effective treatment options. Yeah. So I guess I just thought of something else that maybe Albert may have touched on, and again, this is something that Josh Ho, one of our former trainees, who's now at the University of Minnesota, and where he has developed this technique of using the back layer of the cornea without cells, putting it on the surface of the cornea. And I know he's doing a trial with that. So that's if somebody wanted to, I just thought of that. Somebody wanted to be in a trial, in some kind of interventional trial, that that trial is available at the University of Minnesota. It's not something that will permanently fix the cornea
Right. That's that
or fix
Brightman
the stem
procedure,
cell
right?
issue. Bright mem, perfect,
Yes.
exactly. So it's not going to permanently fix things, but it may, let's say, it may buy some time, because from the time that procedure is done till conjunctiva sort of grows back, this probably this decimus membrane or this tissue that's placed on the front surface of the cornea likely does help preserve the function or health of the epithelium for some time before sort of disease recurs. So that, I mean, that's still under study. So I mean, we don't know exactly, but he is specifically studying this very question that may buy some time for us. Basically,
Right.
that's the
And given that we have other things on the horizon, buying some time might, be really
might
helpful.
be exactly perfect. That's
Okay.
exactly right.
Okay. That's great. Um, so one quick question, just because I think this is important. Lindsay asked, what is the rejection rate of an artificial cornea for aniridic eyes?
Oh, artificial cornea, not low, because I mean, you still need. I mean, you may still have to be on some drops, but not, or depending on how much information they have, a little bit more. But because that central piece is plastic, there's no, or I should say, no immune rejection. But
Right.
the issue is, but if you think of rejection more generally, say, meaning that it didn't work and the body didn't quite like this tissue, yeah, that could be a problem where there could be, these membrane formations. I mean, some eyes that have had multiple surgeries are prone to this fibrosis. So um, let's say, but long term, I guess if the question is long term, how many eyes with those artificial corneas develop some kind of problem? It's not low. I mean, I would say
Okay.
1/3. If I'm just going to throw out a number, I would say 1/3 of the eyes long term will probably get into some kind of problem because of that artificial cornea, which
Okay.
is why, like I said, we really keep it as a last resort.
That makes sense. And particularly because if they develop a complication with that, it can be catastrophic to the eye, correct?
Perfect. That's exactly right. That's the issue, unfortunately, right there.
Whereas with the stem cells, if for some reason we reject it, it can be done again, or it at least is not catastrophic to the eye, correct?
Perfect. Exactly. You don't lose exactly. If it's
Okay.
rejected, you basically go back to what you started.
Um, and then still related to the same thing, without the stem cell transplant, how long will the bright mem last, or is that going to depend really on each person?
Yeah, perfect. Yeah, I think it's good to depend on how much reserve they have, how much
Okay.
stem cell function they still have. Um, yeah, and yeah, hopefully that's one of the questions that Josh will be able to answer for us.
Yeah, hopefully that'll be great. All right, I have kept you 10 minutes over what I promised and everybody else. But this has been really a delightful discussion, Dr. Djalilian. I really appreciate it.
Uh,
Let's everybody else stay tuned because we may have a part 4 of the cornea after we have the ANA symposium coming up this fall. And after that, we might do one focused on more of that basic science so that real, we're not talking in mice yet. We're still in I'm going to call it petri dishes because that's what we as patients tend to
right.
call it. And if we do that, we'll see. We'll round that out with Dr. Jim Lauderdale probably. If we end up doing that, discuss more of the basic research if he has something more to share with us. A recording of this is going to be available on the ANA website and on our YouTube channel, as well as a transcript, so that if anybody wants it translated, we do have, translation of abilities on the website. But before we leave, it's always nice if everybody can, if you're willing, turn on your camera. We'll turn off the focus mode here. It always takes me a second to do all that. I will unspotlight us so that we can kind of see everybody. But it's nice to see everybody who's here. So many friends. And again, I'm having a hard, there we go. Now I can remove my spotlight. But would love to see anybody if you're willing to show us who's here. So many friends that have joined us. Thank you all for being here tonight. It's always encouraging to remember that alone, we in the Aniridia community might be rare, but together we're strong. And with researchers like Dr. Djalilian And some of the others we've heard from Dr. Chung, Dr. Freeman, with those working, we do have a lot of hope on the horizon for new treatments, for exciting things. And it's wonderful to know that that's out there. Um, so if you have feedback about tonight's episode or suggestions for future topics, I won't lie, I have like a 3-page list of things that I want to do in Focal Point here eventually, but I'm always taking new suggestions too. So you can email them to focalpoint@aniridiana.org. I'm going to leave this active for a few seconds in case anybody has anything else to say in the chat. And otherwise, we'll look forward to seeing you at the next episode. And Dr. Djalilian, thank you again so much for joining us tonight. I really appreciate everything that you contributed.
Thank you. Thanks to you and everyone who sent in those great questions. It was fun. It was fun to chat with you.
Thank you. It was delightful. I really appreciate it.
My pleasure.
All right. Have a great evening, everybody, and we'll hopefully see you again soon.
Great.
All right. Good night.
Bye bye. Good night.